Hi there, you're in the lab with your mate JJ. Today is Maxitronix Day. Today we're going to keep on keeping on with our Sensor Robot 20, which we affectionately refer to as our 20in1. Today we're up to project number 19, nearly finished. Just this project and the last one to do. So this is the penultimate project, number 19, the touch buzzer. So we'll pop over to the computer together and have a look at the instructions. Then we'll pop over to the booth and we'll assemble the circuit. Once that's done, we'll bring it over here to the bench and we'll have a look at the circuit under the thermal cam with the oscilloscope, just to see how it behaves. So first things first, let's have a look at the instructions. Here we are on the computer. So just going to open up our instructions. So this is them. This is project number 19, the touch buzzer. What it does: your sensor robot has detected water on the touchboard sensor. Now your robot can show you that your fingers conduct electricity too, especially when your perspiration level rises. Notice that the touchboard is actually two intertwined strips of copper. After you connect the circuit and turn on the control, touch the board. The buzzer sounds. Your visitors can use this as a special doorbell. How it works: when you press your finger on the touchboard, current flows from one strip circuit to the other through your finger to the base of Q1. This is Q1 down here, attached to the buzzer over here, the touch panel, sorry. Touch panel here, Q1 here. Okay. The current is so light that you never realize it's there, but your sensor robot knows. The weak current at the base of Q1 turns Q1 on, and current flows from the emitter of Q1 to the base of Q2. This is Q2. In Project 1 and Project 6, you used a Darlington circuit. In this project, you use Q1 and Q2 as a Darlington circuit. Okay, so that's the transistors connected in this configuration is referred to as a Darlington. When Q2 is on, the output of the Astable Multivibrator in block 2 loads the base of Q5, which is here. This causes Q5 to cycle on and off in time with the frequency of the multivibrator square wave voltage, so the buzzer sounds. Okay, so we've got our square wave producing our tone here, and when Q5 is active through the Darlington circuit over here, then the buzzer will be active. So cool. Alright, well, let's pop over to the booth and let's put this thing together. Here we are in the booth. So our first job will be to take the wires out of the old circuit, so let's do that first. Alright, well, that's the board ready. I've left the one up there, which is our custom. So the next move is to wire in our new circuit, so let's do that now. Alright, so that's all of the wiring done. We've just got to plug in the touch sensor, and we'll do that when we're over at the bench. So let's duck over there and have a look at how this thing behaves. Here we are on the bench. Just going to fire up the old power supply. Now that'll be here. So we've got positive and negative terminals. We'll make sure we get them the right way around this time. We don't want to have a repeat of last time where I plugged them in the wrong way. There's negative, and there's positive, Alright, well we haven't turned it on yet, and it's switched off here. That's good. Now I'll just get our little wedge so we can take the glare off the board. That should be a bit better for you there. Alright, now I suppose we should wire in our touchpad, which I believe is the blue. It is. Alright, so we attached the banana plugs to the touch sensor, so now we should just be able to plug those in like this. Alright. Now I'm pretty sure it's touch to activate, so let's see if we can get that working. Let's power on over here, delivering 9 volts, power on here, should be silent, which it is. It's drawing 11 milliamps. I'm going to lick my finger, make it a bit moist, and touch, and there we go. That triggered, and because it stayed wet, it stayed on. Isn't that interesting? Now we're going to do some more investigation of this, but before we do, I want to switch out the alarm for the LED, which is what we usually do, so that we have a light instead of a buzzer, because the buzzer makes a lot of noise and I find it really quite distracting. So let's try taking out that and putting that in there. Now if we're turning back on, there we go. So that's working as it should. It's very sensitive because of the Darlington transistors. So that's great. Alright, well, what are we going to do? I suppose I should tell you. Actually, I might even be able to. Just give me a second. I'm going to be back in a sec. Hang on. Alright. Well, I'm back. So I wanted to show you the power supply there. It's drawing 11 milliamps. Do you see that? It's the second number in the blue, 0.011 amps, which is 11 milliamps. Now what I'm going to do is I'm going to activate the circuit by touching the touchpad, and the LED's gone on, and it hasn't affected. Oh, hang on. There it goes. Just draws an extra 1 milliamp. Not very much at all to power the LED. So that's the difference there at the source of the power. So I'll throw it back over to the bench. Okay, so we've had a look at the power. We should. I suppose it's worth explaining. If you haven't heard of a Darlington transistor before, the Darlington transistor configuration is the one that you see here with Q1 and Q2, and as you can see, the emitter of Q1 runs into the base of Q2, which essentially just couples these transistors together, and in this configuration they're called a Darlington, and it means that a very, very weak signal on the base of Q1 can be amplified quite a lot, so that it actually comes through a very weak signal can actually drive this second transistor. So what that means in effect for us is that a very, very small resistance that's present when we press the touch panel turns into enough to drive the LED. We take our finger away and it goes off, but the very weak signal there is enough to trigger the Darlington. So yeah, cool. Now we do have an Astable multivibrator down here in this part of the circuit, and that's creating the oscillation that we pick up as our tone. So if we attach our scope, we should be able to see that signal. It'll be coming out Where do we usually see it? Across the base and the emitter of Q1, is it? Q5. Yeah, Q5. So let's try that. No, this is not right. Yeah, it's weird. We always have this this noise. Anyway, let me show you what we're looking at. Throw it over here. Alright, so it's picking up a pretty noisy signal there when it's not activated. Let me be back in a sec. Alright, I'm back. So I just want to show you the square wave output that we're looking at coming out of the multivibrator down here. That's on the scope. You can see that up the top there. It's this odd looking square wave. It's got a lot of noise on it. I don't know why. So when we activate the sensor and the light goes on, you see the LED is a light, then the square wave tidies up. It gets a better reading. So what we should be able to do is go into measure and add, and we'll add a frequency. Okay, and there's our frequency there. It's 1.67 kilohertz. That's normal. It's jumping around again. It did this last time as well. So the frequency is not really steady when you get the measurement down the bottom corner. It looks pretty steady on the scope, wouldn't you say? Anyway, let's activate the sensor. The red light goes on. Does the frequency? Yeah, the frequency does settle down. It's a pretty reliable 1.59 kilohertz there. The square wave looks good, so we do get a better signal when the multivibrator is properly connected through. So I think perhaps we're looking at the wrong signal. Let's take this off here. What about if we looked at the collector of Q4 and the base of Q4, and if we just hit auto on that, wow, that's really interesting, isn't it? It's not steady at all. I don't know what to tell you about that signal. Again, the frequency is jumping everywhere, but I can't account for it. I don't know why it behaves as it does. I wonder, is there a ground? Where's a ground? Something on ground. But the emitter of Q3 is on ground. So where's Q3? There. Okay. Oh, maybe there. That's a bit of a better signal, isn't it? Yeah, right. It doesn't trigger reliably though, does it? And again, the frequency is all over the place. I'm not sure what pins I should use to figure out what signal is on the base of Q5. The base of Q5 is here. That's the base of Q5, and then any old ground should do, shouldn't it? So the emitter of Q4, where is that? That's over here, the emitter of Q4. So I might just use, I need a jumper. So the emitter of Q4, we'll hook him up to ground on our probe. Alright, well that is actually working fairly well. And we hit auto calibrate on the scope. Okay, that's what we wanted to see. So let's just zoom in a little bit. There we go. Alright, so we're looking at the signal that's coming out of our Astable multivibrator, which is exactly what we wanted to see. So we've got it connected to the base there, and we've got it connected to ground on the other side. It's interesting that that 10K resistor actually made a difference, didn't it? Well, I'm not sure. Anyway, it's working now. What we should see is the signal quality changes a bit when the circuit's actually active. So let's activate the circuit by touching the touch panel, and the light goes on, and look at that. The output signal changes quite a lot. We take our finger off and it goes back like that, and we put it on. Wow, look at that. So yeah, okay, that's really cool. We can affect the signal by only engaging the, because of course it's an analog signal, so the harder I press, the lower that signal goes. Of course, if I wet my finger and then press it, it'll go all the way down to the bottom, and we should be able to recalibrate there on that signal. Yeah, but it's not reliable. It jumps all over the place. Fascinating. All right, so we do actually get a pretty good signal out of the multivibrator when we don't have it connected to the tone. So that's interesting. Now I suppose we've got to show you the thermal behavior of the circuit. So where are we going to do that? Let's throw you over here. Now we're looking at the circuit under the thermal cam there on the right. You can see the two resistors in the multivibrator getting warm, as they usually do. There's something that's glowing a little bit. What's that? Must be the oh, it's the screw on the back of the reset switch. Okay, that's fine. Is there anything to see over here? We might just move this across a bit, just to see if there's anything happening on the other side. Let's activate the circuit and see what starts to warm up, if anything. Something starting to warm up? Yeah, a couple of resistors there getting warm. Okay, well the resistor up the top here, that's getting warm. That's the resistor that's attached to the LED. And then there's this 1K resistor over here, which is getting warm as well. And that's interesting. And what about on the other side here? That 1K resistor is not getting particularly warm. This one here, it's not getting particularly warm. What about if we take the circuit out? So things should start to cool down a little bit. I wonder, are we going to see that warm up on the other side there? I'm not sure what to expect there. But you can see that the other resistors are cooling just a little bit. It's funny, once they warm up, they hold their heat for a while, don't they? Alright, well I think that's everything there is to see. We had a look at the output of the multivibrator, we saw the configuration of the Darlington. So I'm going to throw you over to the farewell cam so that we can wrap up. And that's a wrap. So that was an interesting circuit, wasn't it? We used our Darlington transistor for the first time. So this was similar to the other circuits that we did, which were the rain detectors and the water level detectors using the touch switch. But for the first time, we put the touch switch into a Darlington transistor, and it massively increased its sensitivity. So a very weak touch on the sensor was enough to trigger the output, and that was because of the Darlington configuration of the transistors. We had a look under the thermal cam, and we saw the 1K resistors in the multivibrator getting warm, which was normal. We're used to that. We've seen that a few times now. The square wave comes in and out. It gets affected by whether it's connected to an output or not, which is surprising. Well, at least it surprised me a little bit. What else is there to tell you about this? Obviously we switched out the buzzer for the LED, just so that it wouldn't make a racket. And we saw our 1.57 kilohertz tone. So yeah, I think that's everything to tell you about this one. There's just one more to go, and then we're finished with our Sensor Robot 20. So expect that to be coming out in the next couple of days, and then I'll do a conclusion video as well. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.